Humanity's furthest envoy travels through the immensity of interstellar space. NASA's Voyager 1, which was launched in 1977, is considered the ultimate exploration accomplishment. In addition to transforming our knowledge of Jupiter, Saturn, and their numerous moons, this mission gave us our first close-up look at the mysterious and fascinating planets Uranus and Neptune. While watching this video, keep in mind that the two Voyager probes are still in operation and are traveling into interstellar space, which has never been visited by a human-made object. But as they travel through this unexplored region, a disturbing event is taking place on board one of NASA's famous spacecraft from the 20th century. It detects spooky signals from interstellar space. Does Voyager simply run into an unidentified force? Do these signals indicate either warm welcomes or possible threats from alien beings? Come explore Voyager's incredible voyage and the puzzling signals that have fascinated scientists for decades. Voyager 1 and Voyager 2 have traveled more than 15 billion and 12 billion kilometers since launch, respectively. Think about the ambition that led to the founding of Voyager, its incredible accomplishments, and its enduring impact. Think about how these two probes and their findings have influenced later missions and even influenced NASA's work today. When you have more time, imagine the day when our sun will turn into a crimson behemoth billions of years from now. By then, Earth will no longer be livable and humanity will have followed the Voyager mission's lead and sought safety on another celestial body. The idea that the Voyagers will continue to represent Earth even in that far-off era, each one acting as a time capsule from a time when daring explorers on our pale blue looked out to the stars, is both inspiring and humbling. Beyond the Voyager mission's scientific accomplishments, the probes themselves have captivated the world's attention by delivering the golden recordings, which are greetings for possible extraterrestrial civilizations. Simple metal plates were carried by Pioneers 10 and 11, but Voyager's golden records were much more ambitious. They were packed with sounds and pictures that gave any prospective discoverers a glimpse of Earth's rich culture and variety of life. Combined, the Voyager mission visited more planets, found more moons, and took more pictures than any other spacecraft in NASA's history, making it one of the agency's most ambitious projects. One could wonder why there were two Voyagers. During NASA's early years, flying systems frequently experienced abnormalities that required safe mode and instrument shutdown until additional instructions were received. Because the Voyager missions were flyby, anomalies could result in missed scientific opportunities and mishaps. Therefore, having two spacecraft improved the mission's odds of success. Spirit and Opportunity, the Mars exploration rovers, eventually adopted this tactic. Looking back on their extensive solar system explorations, the Voyagers changed our understanding of the outer planets by offering priceless insights through tens of thousands of photos and data. They provided our first in-depth understanding of Jupiter's atmospheric dynamics, for example, demonstrating the Great Red Spot's counterclockwise spin and its interactions with lesser storms. Particularly with their groundbreaking views of the outer planets of our solar system, the Voyager missions represented important turning points in space exploration. They were notable for being the first missions to find a thin, dusty ring around Jupiter. They explored Jupiter's moon Io and discovered its volcanic activity. They also discovered that Europa's linear features suggested a possible subterranean ocean, and Ganymede is the largest moon in the solar system. They examined the makeup and structure of Saturn's atmosphere as the spacecraft passed it. Subsequent missions have validated the concept that Titan's surface contains liquid hydrocarbons, which was first proposed by Voyager 1's observations of the planet's dense cloud. Along with finding gaps and waves in Saturn's rings, the missions also helped Voyager 1 find three previously undiscovered moons: Atlas, Prometheus, and Pandora. While Voyager 2 headed toward Uranus, Voyager 1 continued its journey outside the solar system. Voyager 2 found 2 unidentified rings and 11 new moons on Uranus, but several features, like as the planet's odd magnetic field and constant temperature throughout latitudes, were still unclear. Neptune, the last stop on Voyager 2, revealed 6 additional moons and rings. The spacecraft discovered volcanic vents on Neptune's enormous moon Triton and investigated the planet's magnetic field and composition. In the end, both Voyagers entered interstellar space and crossed the heliopause, the point at which the pressure of the interstellar medium overrides the solar wind. Analysis of electron oscillations during a solar explosion indicated that Voyager 1 had officially entered interstellar space in August 2012. Since interstellar space had a higher electron density than just inside the heliosphere, this discovery went against predictions. On August 25, 2012, electron oscillations and a notable decrease in solar particles were used to determine the departure date. By coincidence, Voyager 1 was 11.5 billion miles from the Sun at this time, and Neil Armstrong had died. The enormous region between stars, known as interstellar space, is not devoid of substance. About 28% is made up of helium and 70% is made up of hydrogen, both of which came from the Big Bang. The heavier gases and dust produced inside stars and expelled into space by supernovae make up the remaining 2%. The interstellar medium is essential since it is where stars are born, despite its sparseness. For stars to form, the interstellar medium must contain both thick and thin parts. Stars are born in these areas, which are referred to as stellar nurseries or molecular clouds. Simple atoms like hydrogen and helium made up the universe at first, but when stars aged and experienced supernova explosions, they discharged more complicated elements into interstellar space. In contrast to the early cosmos, when planets were non-existent, this process made it possible for stars with planets to develop. This process depends on molecular clouds, which serve as star-breeding habitats. Planets like Earth, which may harbor life, are the result of the materials in interstellar space becoming more complicated due to the changing elements in stars' innards. It is a historic moment as the explorers cross the heliopause, the border between the solar wind and interstellar space. It was the first man-made object to journey into this unexplored area, where neither a spacecraft nor a human-touched object has previously gone. Scientists expected to discover new things about space travel and the basic question that has captivated people for centuries: are we the only ones in the universe? The finding of exoplanets, especially those inside habitable zones and in the size range of Earth, has heightened the hunt for extraterrestrial life as we explore the expanse of the cosmos. The Drake equation gives optimism for identifying the presence of sentient civilizations, despite its many unknowns. The seeming quiet, referred to as the Fermi paradox, begs the question of why we have not yet come across extraterrestrial intelligence despite the universe's enormous potential for life. Important data from Voyager 1's voyage into interstellar space has shown how charged particles from the Sun interact with those generated by other stars and revealed severe cosmic radiation. The spacecraft still amazes engineers despite its age. In December 2017, for instance, Voyager 1 successfully activated its backup thrusters, which had not been used since 1980, demonstrating its robustness and possibility for a longer operating life. Our growing technical prowess gives us optimism that we might eventually discover the answers to the universe's puzzles as we stand at a turning point in the hunt for extraterrestrial life. A signal from NASA's Voyager 1 spacecraft, which was launched 46 years ago and is currently speeding toward the outer reaches of our solar system, far beyond Pluto's orbit, was just detected by the California-based Allen Telescope Array, marking an incredible accomplishment. To connect with Voyager 1, the observatory, which is devoted to the hunt for extraterrestrial life, used 20 of its 42 dish antennas, each of which is more than 61 meters wide. The nature of the signal is still unknown, but the telescope captured 15 minutes of data that was saved on a disk. Theories concerning the signal range from the unnerving idea of aliens taking over Voyager 1 to experiences with unexplained forces in space. Although it is unclear whether the signals are a pleasant greeting or a possible danger, some even propose that they are messages from higher civilizations to humans. NASA's Deep Space Network is still monitoring Voyager 1 as it continues its voyage, some 151 billion kilometers from Earth. At 160 bits per second, its data transmission rate is still moderate. The probe, which is powered by a technology that turns the heat from the radioactive decay of plutonium into electricity, has produced invaluable information despite this low data transfer speed. However, NASA has difficulties keeping Voyager 1 operating since the power output drops by roughly 4 watts per year. Triage procedures have been put in place, such as shutting off the heater of the cosmic ray detector, which was previously essential for heliopause transit determination. The declining power output is a crucial factor, even though the final two instruments might continue to exist for a few more years. If all goes according to plan, the Voyagers might only be around for a few years, possibly even into the 2030s. However, these spacecraft will continue their interplanetary travels even after their instruments are silent. Our closest neighbor, Proxima Centauri, will be passed by Voyager 1 in around 16,700 years, and then by Voyager 2 36,000 years later. Both will remain in orbit around the galaxy for millions of years, beyond the heliosphere's destruction and the collapse of our Sun. During their journey, these recognizable spacecraft might transmit a last message recorded on golden records made of copper that has been coated in gold and sealed in aluminum covers. Images, sounds, and messages intended to acquaint Earth and humanity with possible alien civilizations are contained in these documents. In addition to a pin and instructions, they offer a window into our world, its inhabitants, and the scientific accomplishments of one of NASA's most ambitious projects, the Voyager expedition.